Alright guys, we're going to continue with Unit 8, Acids and Bases. Notes, we're going to do Part 6. And this one has everything to do with calculating the pH. Calculating the pH with multiple weak acids. So I've got a sample problem in your supplemental notes. This is example 14.9. Forgot to write it on the top. So we're going to calculate the pH of a mixture of weak acids containing 1.00 molar hydrocyanuric acid, which is the Ka of 6.2 times 10 to the negative 10th, and 5.00 molar of HNO2, which has the Ka of 4.0 times 10 to the negative 4th. Okay, so that's one question. So calculate the pH. That's the first thing we need. Also, calculate the concentration. So the next thing we need to know is the concentration of Cn minus. But we'll do that after. So first we're going to focus on the first part and the second part. Now, generally your AP questions aren't going to have two questions embedded in it. By generally, I mean they don't. So the way the long answered ones would go is they'll ask a little bit, then they'll ask a little bit, and they'll ask a little. So this could be like first part of a question and then this is the second part, but from the textbook I take things from, it all comes together and they're asking for two parts in one question. So, all right, so we're going to solve this pretty much the same way we did before, which is first just listing your major species, right? So we know it's in solution, so we're going to have water. And then we've got these two acids, and you don't recognize those as your strong acids, so you know they're weak, so their whole molecules are going to be what you have a lot of. So, when you're trying to calculate the pH, you need to find the concentration of hydrogen ions. All of these can produce hydrogen ions, which means we need to write our formulas for the dissociation of all three things here. I'm going to list my acids first, just because that's how I did it earlier. So I'm going to start with this guy. So I've got HCN, when it's aqueous, can break apart into a hydrogen ion and a cyanide ion. The Ka for this we have in the equation, but I like to list it next to it because it keeps me organized. It keeps all my thoughts in one place. So here we go. All right. The next acid we have is HNO2 aqueous. And again, I'm just doing my acids first just because that's how I did it earlier when I wrote the problem. If you did water first, that's perfectly fine. So this releases its hydrogen. And it releases its nitrite ion. This Ka is right here, 4.0 times 10 to the negative 4th, a bit stronger of an acid than our HCN. And lastly, we have water, H2O. And that's going to break apart to our hydrogen ion. If you are not used to writing this yet, you haven't done enough of the practice problems because we write the dissociation of water a lot for these. And we have this memorized, that the dissociation of water constant is going to be 1.0 times 10 to the negative 14. Again, we didn't give a temperature, so you always assume it's at 25 degrees Celsius. If it wasn't at 25 degrees Celsius, they would give you the proper kW for this, for whatever temperature you got. So if we look at these, you're going to notice that here, that is your strongest acid. And it's by a lot. If you notice, this is negative 4 compared to negative 10, negative 14. Like this is a lot of a bigger Ka. So this is going to be where you're getting most of your H+. This is your dominant acid. So the rest are just going to actually push the equilibrium the other direction. This is going to push this that way and this that way and all that. So to solve for the pH, we're going to it's almost as if this is the only acid present. So we use our Ka equation. 4.0 times 10 to the negative 4th. And remember, we're using this guy because this is our dominant acid or our strongest acid. And that produces a hydrogen ion a nitrate ion, and HNO2. Now you could do your ice chart. We've done a lot of our ice charts, so I'm going to assume you know what to plug in here. So remember, this is going to be X, this is going to be X, and this is going to be, so this would be your initial concentration minus X, 5.00 minus X, but we're going to make that approximately 5.00. So this is approximately X squared over 5.00. So if you don't know how to do this, get these, go back to the old notes and figure out, I would have gotten this from an ICE chart, from an ICE chart, where these are X and that's X. All right, we're going to multiply both sides by 5.00, and then we get 2.00 times 10 to the negative 3 equals X squared. We take the square root of that. 4.5 times 10 to the negative 2 equals X, which is also your hydrogen ion concentration. So now that we know our hydrogen ion concentration, with that, we can solve for pH. pH is the negative log of the concentration of hydrogen ions. So this is the negative log of 4.5 times 10 to the negative 2. And I'm going to say it a million times. This is where we get our magnitude. This is how we figure out how many sig figs after the decimal. So since this is a negative 2, you're going to ignore the negative, and then you go one less. So 2, 1 less than 2 is 1. So I know my first, it's 1 point something. And I know it's 1 point something something because I've got 2 spots. For this, you're going to plug it into your calculator, so it's 1.35. And there's your pH. So we've answered the first question. For the second question, we want to know the concentration of cyanide ions. So we're going to have to use this Ka expression to solve for that. Okay, so now let's just, second part of the question. So this is the concentration of cyanide ions equals, so we know in case you look back to your notes and say, why did I start with a new Ka, right? So now we've got Ka equals, because this is for HCN, this is 6.2 times 10 to the negative 10th equals the concentration of H plus times the concentration of Cn minus over the concentration of HCN. Now, if you remember, the major dominant species to give us the H plus is going to come from HNO2, which we solved for H plus down here. So this is your overall concentration of H plus that we're going to use at the bottom. So 6.2 times 10 to the negative 10th equals, instead of H plus, now I can put in 4.5 times 10 to the negative 2. I don't know my concentration of Cn minus, so I'm going to call that X. And on the bottom, I've got the concentration of HCN. So the concentration of HCN, we're told that we put in 1.00 molar. And this is a weak acid, so that's really not going to change much. It's going to be 1.00 molar because even if it breaks down a little bit, first of all, we got a driving force pushing it back because it's not the dominant acid. So it's not going to make much H plus, and then whatever it does make, it really gets pushed back. So it's really barely at all going to break apart. So that concentration is still 1.00. And that can go away because we're dividing by 1. So to get rid of this, we're going to divide both sides by 4.5 times 10 to the negative 2. Those cancel. I did it to both sides, so we're equal. If I were to do this in my head, 6.2 divided by 4.5, it's just going to be slightly smaller than 1.5. If this was 6.0, right, then this would, and 4, then that would be 1.5, but we're a little off. So it's around 1.4, and when I do it in the calculator, it ends up being like 1.3 something that does round to 1.4. But if you're doing this in your head for calculations, it's just going to be somewhere around there. If this were maybe a multiple choice where you don't have a calculator, 6-ish divided by 4 would give you 1.5, so it's somewhere around there. And then I have 10 to the negative 10th divided by 10 to the negative 2. So this becomes 10 to the negative 10th minus, because I divided, negative 2. And negative 2, because that's what it was on the bottom. So the minus means divided by, and then the negative 2 is the other exponent. So negative 10 minus negative 2 is like adding, and that becomes 10 to the negative 8th. And that is your concentration of Cn minus. All right, so you should be able to do, I think, number 12 on your worksheet. And let me know if you have any questions. Otherwise, I will see you in the next set of notes or in office hours.